First and foremost, let me welcome you all on behalf of the FOSS community and Mozilla Campus Club of IIT. Welcome to the first day of the open bracket MERN Stack webinar series. My name is Tarin Datanaka and I'm a second year BIA student, and I'll be your host for this evening. This series consists of two sessions, one for back-end and one for front-end. Today, we will be hearing all about back-end development, and our mentoring partner this time is Gapstars, which is a company that is dedicated in finding, hiring, and facilitating developers in a Scrum team format for companies and startups which are looking for offshore developer teams. This webinar aims to exclusively provide heuristic hands-on session alongside mentoring experts who are masters of MERN stack. MERN is a free and open source JavaScript software stack for building dynamic websites and web applications. A quick reminder for the audience, please note that the questions will be accepted during the session over the Padlet link, where you can type your questions. We will share the Padlet link in the Zoom chat in a moment. Now, without further ado, let me introduce the mentors for this session. And as you may already know, it's Mr. Sukitha Jayasinghe, Mr. Randilu Soysa, and Mr. Ishan Amarasekara. We have three mentors with us. Mr. Sukitha is a software architect with more than 10 years of experience in designing and developing enterprise and cloud applications. And he is currently working as a principal engineer at carve.com and Gapstars. And Mr. Randilu is a senior software engineer at Gapstars and also works as a full stack developer at carve.com. And Mr. Ishan is an associate technical lead at Gapstars, and he's also working as a front-end developer for carve.com. And he's also a UI design and web development expert and has good experience in working with REST API and microservices. And with that note, I would like to hand over the session to our lovely mentors for this evening. Over to you.
Hi, everyone. So welcome to the MERN Stack web series. Today, we are going to talk about the backend API development. And tomorrow, we will have a session to implement whatever we are building today and build nice web UI. So today we are focusing more on creating an API, especially the REST API, and then we are going to add routes, and then we are going to add methods, and we are going to add some advanced functionality into this API, like API documentation, then some authorization into this, and then we are going to deploy it into the cloud as a serverless application. So we are trying to cover as much as possible, but we will make sure that the code is available there. If we, whatever we cover, like additional will be there in our Git repo. We'll share that, and then we'll make sure that content is there. So you'll be able to go through that and you can learn more. So let me start just sharing my screen. Okay, so today we are going to talk, build our API on top of the MERN stack. So MERN is basically Mongo, Express, React, and Node.js. So M of MERN is Mongo. Mongo is a NoSQL database. It's a document type database. And NoSQL database today are like very popular. So there are like different type of NoSQL databases. Mongo is document based NoSQL database, and it's schemaless, which is a huge advantage. So you can define your schemas based on your requirement, and you can dynamically change it, and you can add additional attributes into the schema without hesitating. And then we have the Express. Express is the standard web framework for the Node.js, and it's small, it's fast, and it's robust. So it's evolved many years, and it considered as a de facto um, web application framework for the Node.js, and it really good for building APIs, especially REST APIs. And then for Node.js, you all love it, and Node.js is a server-side JavaScript runtime. So this is run on top of the V8 engine, and thanks to the Google, they have made the Chrome V8 engine open source, and then smart engineers managed to get it and make it ready to run on any OS, like Windows to Linux. On any OS, once you write Node.js application, you will be able to run on all of these platforms. So it's really a nice project to go and visit. So I'm not going to deep dive into it. So I highly recommend you to go and read about it, read about the event loop, asynchronous, like event driven architecture of the Node.js, and how they achieve the performance by applying like really nice design and architectural techniques. So all the MERN application looks like this. So you have React.js application run on web, which is on your client machine, and then you have Express.js web server running in the server side, which is run on top of the Node.js runtime, and then you have the MongoDB, which persists your data. So if we dig deep into the architecture, we are more focused on the backend server now. We are going to use two npm modules. One is Express, you already know about it. Then we are going to use Mongoose. Mongoose is ODM type of database utility. ODM means like object, yeah, data modeling. And then Randilu will explain you how to model your data structures in code, and then how you run different operation on top of that. Then it will connect to the MongoDB native driver and go and execute these queries on top of the MongoDB. So you don't have to write any query manually. You can just model it, use it, and just use standard Node.js method to work with the database. And this is the application we're going to build. This will be our output, and I'll invite Ishan to talk about this. It's over to you, Ishan.
Yeah. Thanks, guys. Can you all hear me?
Yeah, you're good.
Okay. Okay. Let me share my screen. Okay. Uh,
Yeah, please.
yeah. Let me share my screen quickly. Okay. So we are gonna look at an application that I think that we'll be able to get going in here. So this is that application. Basically, this is done using React, React.js, and we have used some libraries like Bootstrap for this, and you'll see how we gonna do this tomorrow. So basically, it has functions like there are like the in progress list and a complete list of. This is a to-do app, so there are the in progress list and a completed list. You can click on a item, and it'll move to the completed list, and like you can do it vice versa as well. And like you can go for a compact list. Like tomorrow you'll see I'm not using two components for this. It's the same component, just through Bootstrap and JSX. I'm maintaining it in a way where it will show different sorts of output just by uh, handling its UI components, and it supports responsive designs as well. Uh, like if you go here and you can scroll it. Oh, wait, give me a sec. Uh, this way. Uh, you can click just like previously, but at the same time you can edit uh, you can delete an item. Yes, and it will go away. At the same time, give me having too much of these. You can add a new task here. Just you have to add a title here. Title now and description, and you can save it, and it will come on top as we are doing the sorting here by the created time and the updated time. So we'll go through each of these tomorrow, but for now I think Sukita will take it from here to explain more about the backends and get it started. Yeah, over to you, Sukita.
Yeah, thank you, Ishan. So we display what we are going to do. This will be our output, but to go there, we have to do a lot of things. First, we have to go and create the API. And what is an API? API is stand for application programming interface, and it's the way two software components communicate each other. So let's say you want to go and okay, you log into the Facebook and you want to see the post or you want to make a comment. Then how it happens is there is an API open from Facebook, which is hosted somewhere in maybe in US. And then from your browser, you make a request to this server. So these requests are mostly HTTP requests. So it's on top of the TCP. So once you connect this, connect with the server, once a handshake is completed, then you send your data to the server that I want to do this, I want to query, I want to get the post, I want to create, make a comment. Then server do the validation, do the authorization, and make sure that resource is accessible to you. Then it respond back with whatever the inside the server as a resource. Then this basic mechanism we call the API. So there are like different type of APIs. Today we are going to focus more on the REST API. There are like two other major standard. One is the GraphQL, and another one is the gRPC. So basically, Facebook use GraphQL for their communication, and then most of the Google services has implement the gRPC. But 80 to 90% of API implementations are REST API implementation. So if you go and try to build an API, then most probably you will build a REST API. So REST stands for representational state transfer. That doesn't make much sense, and everybody says that. And but it's a client server architecture. Client consumes resource provided by the server. So key abstraction of the REST API is resource that I will explain in the next slide. And why people like REST API is because the nature of sales descriptive. So when you take a REST API, if you check the methods, if you check the resources and then the resource path and verbs what they are using, then you can easily understand the functionality of the API. So that's the main reason we are building most of the APIs according to the REST standard. So let's go and see how this works, and let me show you this sample API provided by the Swagger. This is called Pet Store. Hope you see my screen. Okay, yeah. So this is a sample. So here I'm trying to access. First, I want to go to the Chrome console. you can go by pressing F12, and here in the network, under the fetch XHR, you will be able to see the request. So I'm going to execute this request, and here I am sending a get request to this particular endpoint. This here, I think you could see the request URL. In the request URL, you see the address, the part I have selected here. This is the DNS, and this is how we address the server. This is the location of the server. Then you see that the V2 is the version of the API, and here you see the resource which we are trying to access. This is what we call the resource. And then you see some path parameter here, that's 10, that's the ID of the pet we are trying to access. And here you could see the request method, that is get. Get means like you are trying to retrieve, you are trying to query the server. And then here you could see the status code is 200. 200 is a success. So I'll explain you more about these parts, because these are like essential component of the REST API. And then you could see response and request headers. These are metadata go alongside with the request and the response. So here, first you can see the request header, the highlighted one. And under that, you are basically sending authorization information in this particular header. So header section. So you have API key. This is one of the like authorization header I'm sending. And then you could see some other information like user agent. User agent is the agent is the information about this particular browser. This has like information about my laptop, and then the browser versions and all. So these are in the request. And if you look into the response headers, this is basically come alongside with the response from server, and response, this basically content type is application JSON. So that if you go here and check the response, you could see there is a JSON output. So in the header, the server has added content type as JSON. So it's easy you to decode and read the data. So these are like basic HTTP elements. And let me go back and talk about the REST part. So what are the RESTful key elements? As we discussed earlier, the main thing is the resource, what is the resource you're trying to access. So according to the last example, it's the pet resource we are trying to access here. And then request verbs. So I think you already have heard about the CRUD operation. So CRUD means create, retrieve, update, and delete. So HTTP provides us similar set of methods. We can directly map CRUD operations into request verb. So if you want to create new pet, then you want to send certain set of data into the server, and we can use post in order to create some resource. And if you want to update, let's say you want to update the color attribute of the resource, then you can still use put or patch in order to update. And if you want to query, and if you want to read pet information, as we checked in the previous example, you could use get. If you want to delete a particular resource, then you could use the delete. So in this coding session, Randilu will explain how we use these request verbs. And then we have request headers. We already talked about it. We have authorization information alongside with that. And we have request body and response body. Mostly these are like JSON. Still, we could see some XML APIs out there, but very rare. But most of the things are like JSON based today. And we have response and response status code, which indicate the status of the response. So there are mainly 5 categories of response. Hope you could see my screen with HTTP response codes. And basically we are looking into 3 categories. First one is 200 category. If you get something in between 200 and 299, that means you have successful response. And if you get something in between 400 to 500, that means like you have some failure from the client side. So let's say if you are not sending authorization information, then you will get some 400 errors. If you sending like bad formatted JSON, then you will get some 400 type of error. So then 500 error means there is some problem in the server. So basically we are trying to prevent this happening. But if let's say your application crashes, or if your application is not able to connect to the backend server, then you mostly get 500 type of errors. Let's go and see 400 errors, which are very common, and most of you already might know about these things. So basically 400 means the bad request. If you send bad formatted JSON, you will get 400. And if you are not passing authorization information, then you will most probably get 401. 404 is very popular one. If you try to access with some resource which is not there in the server, you most probably get the 404. Here in this example, if let me like type something random and hope that won't be there in the server. And yeah, now you could see that I'm getting 404 error. So the meaning of this is the resource is not found. So Randilu will explain more how we can utilize these HTTP codes. And then the JSON is language of communication. This is how we encode our data. If you want to, let's say, create a resource, then you send all the resource attributes in a JSON. If you want to retrieve data, then the retrieve data also coming as JSON object. So these are like very self-explanatory, and then it's like more key value or dictionary. So let's we already so a REST request, and then designing API part. So I'll hand over to Randilu to explain you what are the best practices designing the API. He's going to mainly design the API, and he's going to bring you through the coding session. So over to you, Randilu.
Yeah, thanks, Sukitha. Let me quickly share my screen. So
yeah,
hope you guys can see my screen. So what I'm trying to do here is I'm trying to create a very basic version of the Express API, and what we need is here. So we need Node.js installed in our system, and we also need an IDE. So preferably you can use any IDE, but I'm using here VS Code. So so guys, what I'll do is I'll try to start it slowly. So maybe you guys also can start this with me, but along the session, I'll try to speed the things up, and maybe we could see errors happening, and we'll try to sort these issues by going through this the debug logs and terminal, and we'll see how this will go. So first, what I'll do is I'll try to create a new project. So let me name this as to-do API, to-do app API. So let's name it as V1. So yeah, so let's try to open this up in a IDE. So okay, so now you can see my IDE here. So let's open up a terminal here as well. Okay, so yeah, so what we can do is we can simply create a
new Node.js project. So for Node.js, which is a runtime, so there we have something called a package manager. So for most of the languages, you can see there are package managers. For in Java, we have Gradle and Maven. So similarly, for Node.js, we have several package managers, and we can use npm, and we also have yarn. So let me create a new project with npm. So let's create a new project with npm init within this directory. So we are prompted with a few questions here. So we can just go through this, and if you want, we can add, let's say for description, we can add a description, and I will explain you what this entry point is. And let's for now, let's put yes for all these options. So yeah, okay. So we have to type yes here. Okay, so now we have something called the packet.json here created. So we can see the version is 1.0.0. So I'll also explain a bit about this versioning, and let's see what we can do next. So now that we have created this project, so it's a good practice to include all our source files within a directory called src. So let's try to create a new directory. Okay, and so we can include the index file here. Let's include the index as well. Okay, now we have the index here. So now what we can do is we can, for usually in a server, we need a server to run, to create these APIs. So as Sukitha mentioned previously, we are going with Express. So Express will make our lives more easier with all the helpers and capabilities it provides as a server. So what we can do is we have something called scripts here. So in order to start the server, we need to add a start script. So let's try to add a start script here. So okay, so we can run our index.js file. So in order to run something, we need a node. So how we run this with node is we simply we simply execute with node, and we can give the source file. So in here, our entry point would be index.js. Okay, so since now we have the index file, let's try to add Express. So whenever we need to add a dependency to our package.json, we can use our dependency manager. So I've used npm to create our this skeleton here. So let's try to use something else. So I'll use yarn, and we can add Express like this. Okay, so guys, in this Express framework, we need to create something called the app. So this is the app we would be listening to as a server. So a good practice is to create a separate file to contain all this logic related to the app, and we can have this logic related to all the connections in the index file. So let's try and create app.js file. And what we can do here is we can import Express. Like this. And okay. and we can create a new app. So it's easy as this. And what we can do is then let's export this app, which we have created. Okay, so now we have contained the logic relevant to app here. And let's try to import this app in our index file and to create a way to get this server started up. So for that, what we'll do is we'll again import the app here. Okay. So here we have something called app.listen. So this is the way we could spin up this server. So in here, as the first parameter, we can give a port. So I'll give 5000 there, and we can have a callback function which will print something in the service up. Okay. Let's say so guys, I'm assuming that you guys are familiar with the basics of this JavaScript. So we have used a template editor here. And so a good practice is always, rather than hard coding these ports here, we can include this port in the env. But for now, let's create a local variable here. Let's say port. Okay, so now we have that here in the index file exported, and we have that here created that logic. So now what we need is we need to implement some logic so that when we hit the home route, we can show something. So for that, let's do something like this. So as Sukitha mentioned previously, I'm using the get method here. So in Express apps, we can pass the route here, and we can pass a callback function. So when we hit that route, we can show something. So in here, guys, in Express, the Express will get the request and response from the request created from the client side, and it will assign these values to something called request and response in this callback function. So what we can do here is we can use the send function of this response parameter, and let's try to send something so that we can see it. So let's say okay. So as the first step, I'm going to show this in browser. So for that, it would be better if we could create two h1 tags. Okay. All right. So for the first time, let's try to spin up our server. So for that, since we have added our start script previously, let's see whether it works properly. Okay. So now you can see we have included this string here, and it is now printed in the console here. So now what we can do is let's go to the browser, and okay, now it's running, right? Okay. So, okay, now we have spinned up an Express server. So now maybe let's try to do some change here. And let's refresh this and see. Okay, so we can see that although we have done some change here, but it's not reflected in the browser. So to like if you have done if you have done some programming in with React framework, you have noticed that whenever we change something in the code, it get automatically reflected in the browser as well. So we can add a package called Nodebud so that we can do it here as well. So let's try to add Nodebud and see. So with Yarn, we can add packages using Yarn add command. So there are two types of dependencies, which are the main dependencies and the dev dependencies. So the main dependencies will be used in a production build, but the dev dependencies will be used only in the development build. So in Yarn, we can use the -d flag to say that this is a dev dependency. So let's add Nodebud and let's define it as a dev dependency. Okay, guys, let's go to the package.json. Now we can see clearly see that there are two kind of dependencies here, and we have two versions here. And one interesting thing is, guys, if you can see, we have this caret here, and we have some kind of a versioning here. So this is something called semantic version, which is used in the NPM ecosystem. So what this means is whenever you install these dependencies, it should at least have this this version provided here or something greater than that. So in here, it's really worth to note that we have three kinds of versions here. So the first version to the right is the fixed version, and you also call it the patch version as well. So the next one is the minor version, and we should note that whenever we are installing these dependencies, this will only install the latest version of the fixed version and the minor version. So this is called the major version, which is also called the breaking version. So we should note that whenever we install these dependencies, it won't install the latest breaking version, but it will only install the latest major and minor version. So the reason for this is, guys, so what do you mean by the breaking version is the app won't be backwards compatible with the latest versions if the version is increased with this furthermost breaking version is upgraded, that it might not be compatible with what we have implemented here. So that's something really worth to note. So doing this, then what we can do is, so we can also in the package.json, now we have the Nodebud here, and what we can do is we can update this start script. So instead of node, let's try to use Nodebud and see what happens when we start this one. Okay, so now, okay, now we can see we have the change here. Okay. Okay. All right. So now let's go to here. Let's remove this, and we can see in the terminal it will restart the server. automatically. And if we go to here, the change is reflected here. Okay, so having done that, so now we have created a very basic, actually, a get endpoint. So we could go on adding new endpoints to here, but let's say we could add something like, let's close the server for the moment. So we could add something like here to do, or maybe something like this, post, and both of these the endpoints would be similar, but the difference is we have different methods here, and we can go on adding this. But the thing is, guys, this will clog up this app logic, and in a very large applications, this would be very hard to manage and maintain. So the Express also have solution for this. So instead of defining the routes this way, we have something called the routes. So let's see how it works. Let's see. Okay. So what we have done here is, guys, so it's a like we follow some conventions in developing these APIs. So it's always a good convention to include this API and the version of this API. So so in here, instead of just adding the get with the app, we have something called the route. So what the advantage this brings out is, we can for a specific route, we can chain different methods. So for example, we can add a post to the same route, and we can add a callback function here, so that it would be well defined, and we can separate out the logic for different routes. So for now, let's see whether this works properly. So let's hit yarn start and see. Okay, so now instead of hitting this 5000 route, we can add the version and the API and say to do's. Okay, so yeah, it works as expected. So yeah, so now we have created a basic route here. So maybe you guys also can take some time and maybe to catch up with me. But let's see how it goes. Okay, so now what I'm trying to do is, so even though we have the route here, it will still I would say like clock the logic we have implemented in the app file. But I believe when scaling up, when we are getting so many routes here, so it would be a great thing if we could separate each set of routes to different files, and if you could import these different routes here, and if you could use a single line to represent all these routes. So in order to do that, let's create something called, let's comment out this. Let's close the server. And I'll create a new folder which is called routes. And guys, it's a good practice to always have an index file, and we get the other content of these other files and get them imported in the index file. So we add something like this. Okay, so guys, what we are trying to do is, so in the previous intro slides, we saw that the final product we are going to create. So there are, I think Ishan showed us a list of to-dos. So the magic which happens behind the scenes is that the front end is calling an API which will get those to-dos, which is in a database, which is in a MongoDB, and get them out and get them as a JSON list and provide it to the front end. So what we are trying to do is we are trying to build that API to get all those to-dos. So we can, as we did previously, we can name this API as API v1 and /to-dos. So let's try to add a route here. So for that, let's first import Express here. So in Express, we have something called the router. So let's try to create a router here. Okay, so as we have done previously in the app file, so now what we are doing is we have created a router from Express, and we have given the path here, and we have specified the method here. This could be get, put, post, delete, anything, and we are passing a callback function here. So as we did in the app file, so since this is a Express request, we have this request and response coming from Express, and let's try to send message here. Yeah, so guys, we have done this, and next what we can do is we can use this in our index file. So imagine in a large enterprise application, we might have a lot of routes here. For example, in this case, we have the to-do route, but let's say if you have users, we could have user route as well. And let's say if this is an e-commerce app, we might have orders, products, and so on. So we might get a lot of files with the routes relevant to a specific resource or a resource path. So a good practice is to create all these routes, and we can create a single route in our index file so that it could consume all these routes we have specified in this folder. So for that, we have to again create a router. And for that, we need to import Express and follow a very similar pattern. So let's try to do that. So we are importing these to-do routes from this JSON file. So let's name this as to-do route. Let's create a new router. So here guys, let's see how we can accommodate these routes into our common route. So here we use something called the use method here. And what this allows is we can define a specific set of resources. So in our case, it should be the to-dos. So as the second parameter, we can consume the routes we have created previously in our route to-do route.js folder. So let's include it here. And let's try to export this. Okay, now that we have this route exported, let's see how we can modify the app file so that we can use this route with all these routes specified here. So for that, let's go to the app. Let's remove this. And what we can do is we can simply use app.use. And now here we can specify the path, we would say the base path. So as I have explained previously, it's a good practice to include API and the version here. So now here we can consume the routes, the router. Okay. Actually, we have to import this router. So let's say okay, so now we are using this router here. So guys, you guys might have confusion what this use just meant. So in Express apps, we have something called middleware. So I think Sukitha might do explanation later here with that. But what happens here is, guys, whenever a client makes a request, Express provide us a way to get this request and do something there, which is called a middleware, something called you can do something there. And so then what we'll do is, so the process we used to do some kind of a processing is that we require middleware there. So for example, let's say if we hit a route and if this route is not defined, we can use a middleware and handle that scenario so that we can return, let's say a 400 of 404 not found status. So so that concept is called middleware chain. So that is we can have multiple middlewares here, and we have to define these middlewares in a specific order. So that this middlewares will execute in that given order. So I think we'll see a good example here when we are trying to create a post request. So for now, I'll just keep it like this. And what this middleware do is it'll get the request, and it'll use this router, and it will specify the space path. And when the request hits this path, it will call the callback function, which we defined in the to-do route. So this one. So let's try to spin up our server now and see what happens. Okay. Okay. Now it's up. Let's do something else. This shouldn't work. Okay. Okay, this works. That means our implementation is working now. So what I'll try to do next is, I think before connecting these MongoDB and stuff, let's first try to do something simple. So I'll define.
Mr. Randilu, sorry to interrupt. Some students are asking if you could increase the font size a little bit. Would that be possible?
Okay, let me try. Okay, guys, let me share it again. Let me know whether the size is okay. Can you see the screen?
Yes, we can see the screen.
Yeah, is it? I think this is visible, right?
Yeah, it is visible. Thank you.
Okay, it's okay. No problem. So let's see where we were. Okay, so guys, what I'm trying to do was just create some response in memory, and let's try to fetch this maybe a mock response. So for that, I would say I'll create a new directory, but you don't have to do that. You can just hard code in your source, any of the source files itself. But for clarity, let me create something here. So if you have any confusion of this naming conventions, just don't mind this. If you have done unit testing, you might have met this convention where you have two underscores. So just let's just skip that for the moment, and let's create an index file here. Let's try to create something called todo.js. So I have created some to-dos previously. Let me try to copy those things. Okay. 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 Now we have these things here. Let's try to export these things. Okay. Okay. So okay. So in here we have this mocks folder, and so in basically we are making this project to just to demonstrate about this express service. So usually usually in an enterprise project we have this layered architecture. So there we have this separation of concerns. So we have something called controllers, and we have something called services, and we have something called repository. So these three items can be seen as three layers. So what I'm trying to do is just to give you that experience. I'll create these three folders so that the folders so that we could separate some of our logic there, but it won't be very perfect. Uh, let's try to create a folder called controllers and services. So guys, what these controllers and services are doing is, so in the case of services, services is the place where we handle all our logic relevant to our endpoint, and in the controllers, what we're doing is we just get the request and we just call the services, and we make sure we send the correct status back. That's only we are handling in the controllers. So I'm trying to go with that pattern, but we won't be having a repository layer. We'll handle these queries of Mongo with the service itself to contain this logic there, then and there. And we'll have a control layer so that, as I told previously, we'll just handle the request and just send the correct response back to the client. So let me just create the index files and the service files here. So Okay, guys. Let's I would say let's start with the service itself. So what we can do is let's try to create a function which will return the mock data we have in our mocks folder. Okay. Okay, so here we won't get this suggestion because we have to export it from the index file as well here. So in the mocks, sorry, in the mocks. Okay, so that. Okay. Okay. Now let's try to put it here. Okay. Okay. So guys, let's name our service as the to-do service. So similarly, we can create a controller here. So for that also, we'll use the same naming convention. So as we have done previously, this would be the place where ExpressSphere is passing us the request and the response parameters. So we have to use these parameters here. And what we'll do is let's try to call our service. So the service will return us the to-dos. And believe first, let's see. Okay, we have this suggestion here. Okay, all right. We have this here. Okay. So now guys, what we can do is, now that we have the to-dos, let's try to send these to-dos to the client. So for that, let's use our response parameter here and use the send method there. Okay, so even this seems to be okay, but it's anyway a good practice to handle any of the errors thrown from the service layer, and we can return the relevance status code to our client. So in order to do that, let's wrap this with a try catch. Okay, yeah, the try catch here. Then let's try to send something else. Let's try to send a status. Okay. So guys, you guys would be thinking that why in the in here, why we haven't used a status, but if this response is successful, it will automatically get the 200 status. So for the moment, we'll keep it like this. And let's see, we've got, okay. So we can go on defining these status codes ourselves, but it's a good practice to have something readable, and we might, who knows, we might not remember all these status codes and all. So it's a good practice to have something readable in our statuses. So we have this fancy package called HTTP status. So let's install that and see how we could improve our code here. So let me add that one. Okay, guys, let's see how we could improve this here using this package we have added. So we click here, you can see, okay, we have the status codes here and some type something here. Okay, so here we have the statuses defined and it's very clear. So we can get this errors defined in text, and it will return the relevant status code there. So yeah, that's a good improvement, I think. And let's try to export this one as well. Okay, complete. Let's go to here. So let's similarly, let's name these as the to-do controller. Okay, now we have this exported from here. Let's see how we could accommodate this in our routes. Okay, okay. So now let's remove this one. Okay, so what this means is whenever we hit our to-dos route, which we have defined here, this should hit whatever the function we define here. So now that we have the controllers, let's try to add our controller function here. Okay. Now let's spin up our server and see what we get here. Okay, so guys, let me like we have used the browser previously. So since most of I heard that most of you guys are interested in using some kind of a REST client to invoke these APIs, maybe it's a good point to just go with Postman and see how we could get this response there. So let me open up my Postman here. Let me create a new. Let's click pause. Okay, so guys, this is called Postman, and this is a REST client. So even though we have used our browser previously, the pros we have here is that we can have all the methods here. So in browser, we only get to use the get method, but in Postman, we have all the methods, and we can also very easily set the headers, and we can set the post body, and we have different types of the content types here. So I think Sukitha might explain this in latter part of our session. So what I'll highlight is that we have these headers, and we can set those things, and we have this authorization. It's a whole lot of things. Let's keep it simple. Let's try to access our endpoint. Maybe we can copy it from here and try it here. Let's see whether this works. Okay. I hope you guys can see this. So we have something like this. We have the mock responses, the mock object we created here in the mocks. Now it's converted to a JSON, and we have this JSON data here. So if you guys think what magic happens behind here is that when we are calling this send method in our controller, it will automatically convert this data into JSON, and we can see that JSON in our Postman result. So we have something called a method called JSON as well. So I would say you guys can just do some research and see what are the differences with the JSON and send methods here. So yeah, that you can do. And now that we have created a very simple API to get the to-dos, so I think maybe I'll give you maybe 2-3 minutes maybe to catch up, but I don't know whether it was too maybe too fast. But let's see. The next step would be to create a MongoDB, which maybe to use the MongoDB and see how we could get some persistent data. Okay, let's see. Okay, okay. Let's see what we can do here. Okay, so so as Sukitha has mentioned, how we could use a database to persist this data. So now we have, since we have used something in memory, we need to connect a database. So as our choice is MongoDB, there are several ways to spin up a MongoDB service. We can create one in our local environment, and we have a whole lot of services, service providers as well. So for this tutorial, I thought of going with MongoDB Atlas. So I have already created a DB there, but let's maybe go to our MongoDB Atlas account and see how it's happening here. So guys, this is something free. You guys can create your own accounts and try to create a user here. So and then after creating a user, you can also create a cluster and see how you could create a database. And like the database means that you get something like this. Okay, let's say guess something like this to get a method to connect this DB to our application or something else. So what I have used is this option. So this will give you a connection string, and with the user you have created, you will get a password. And what you have to do is you have to add this password, and then the connection string is complete. So let's see how we can use this connection string and get our MongoDB connected. Okay, let's go to the code. And okay, so so in order to perform the queries and all these data retrievals and all, we need a middle layer so that our app can connect and perform these things on the MongoDB. So we use a library called Mongoose there. And so another important thing is whenever we have something like a connection string, it is something we should keep secret. So we should not commit these things to our repos. So a good way to prevent and keep these things to us is to create something called an env file. So let's see how we could create an env file and how we could read this env file from our application, and how we can keep our connection string safe while using it in our application as well. So let me try it. Okay, so first of all, let's install Mongoose here. Okay, Mongoose is here. And as I mentioned earlier, there should be a way to read this .in env we have created. So there's a package called .env, which we can use. So let's install that as well. Okay. So we are installing both of these packages in one go. All right. Now we have them, and let's see how we could configure these packages. So we use the index file. So in order to .env to extract these details from our env, we have to require this config from the .env in the topmost level of execution in that. So that would be the index.js. So I've added it here. And as I mentioned at the beginning, so now we can move this port to our env, which we have already done here. And let's try to access it from there. So let's keep this here. And how we access is using process.env. Okay, should be port, and we can use this OO. So whenever we don't have this one, this will be undefined, and we can get the port here. So that's that. Let's see how we could connect our database. So for that, let's try to import Mongoose. Let's require first. Okay, we have the Mongoose. And let's have our DB URL as well. And should be, let's check. Okay. Okay, yeah, this. So in order to connect the database, it's very simple. We can use the connect method in Mongoose. So let's try to connect it. here we have to pass our DB URL. Okay, so guys, this will now return a promise. So what I'm trying to do is first we are first trying to connect to the database. Then what we're trying to do is then listen to our app, and whenever an error occurs, we'll try to catch it and log it then and there. So as you guys know, we can chain this promise with a then call, and we have to pass a callback function here. So okay, let's try to pass this one here. Okay, and maybe we can add a console as well to know whether this has connected properly. Let's catch anything. Okay, so yeah, that's pretty much done. Let's try to start this and see what happens. Okay, so guys, now you can see we have this log here and this log here as well. So that means everything is good. Now what we'll do is we'll try to fetch something from the database itself. Okay, so for that, let's go to the services. So we don't need this anymore. Let's comment this out. And okay, so in order to access the database, we need something called the models. So the models is the way that, let's say, for example, these to-dos are structured in our database. So in order to replicate how this our data is structured in our database, we use these models, and we also use something called schemas. The schemas is more like a blueprint where we can create these models out of this. So let's create a separate directory for that. Great. Okay. So let's try to create a schema to our to-do object. I'll name this as to-do schema. Let's close this. Okay, so in this Mongoose library, we have this method called schema. Okay, and we can easily create the schema. Let's say as we had in our Mongo data, let's add a title here for the to-dos, and let's specify the type here. Should be a string, and we have the description. Should be a string as well. And we have the status. Okay. Okay. So guys, like if you guys can remember when Ishan was showing the final product. So he used to have some kind of ordering. So when we update one of the to-dos, and when we look at that list, so whatever the updated ones comes to the top. So in order to build this one, we have to have a created time and updated time, which is saved in the database itself. But we don't have to go through all this hassle. So MongoDB itself create these timestamps for us, but we have to include them in our schema. So we can do that by adding this timestamps property. Should be a property, sorry. Okay. Okay, this is it. So as I said previously, this is some kind of a blueprint, and we have to create a model out of this. So I'll explain further on this, how this model will be utilized in the database. So let's first create this model. I'll name this as to do. Let's export this. Yeah, so in the beginning, this could be a little bit confusing, but what actually happens here is when we create a model, we usually use the uppercase and the singular text. So what happens is when we connect the database and when we try to create a new resource, this model will convert it to a collection where this could be represented in plural form and full lowercase. So it would create something called to-dos there, and that's what this model is doing. So let's see how it works. And we have the schema. Let's go to the service layer. Okay. Now let's try to access this. We have this here, and we have to export it here as well. Yeah. Say the model. Okay, we have it here. Okay, guys. So now that we have this model, the power is with this mongoose is that we can, as Sukitha mentioned previously, we can do some operations here. So what I'm trying to do is I'm trying to get all these to-dos we have, and for that we can use something called find here, and usually we can specify some kind of a query here so that the to-dos relevant to that specific criteria will be picked up. But for the moment, let's keep it empty and see. So this is an asynchronous operation. Let's add async flag here and see. And let's try to go to the controllers. Okay. Now, since this is an asynchronous function, let's add await here. Okay. So very here. Do this. Okay. Should work. Should work. It's okay. Getting an error here. Let's see. What's the issue here? Okay. All right. Okay. Yeah. Yes. This is the place. Okay. Now it should work. Okay. Now this should be a sync. Okay. All right. All right. Okay. We can comment this out. Okay. Okay. Now let's start the answer. All right. Okay. Let's go to our database. So let's see the collections we have. Okay. All right. So we can see we have few to-dos already. Oh, actually, we have one to-do here. And let's see whether we can retrieve this one. So let me use the postman and let's hit this one. Okay, okay, okay. We had two of them. So apparently we are using this one. Okay. So we have around, let's say, four of the records there. So I think we have these 4 records here. So guys, you can see there's a ID here, but it is prefixed with the underscore, and there's this version as well. So these are default properties which is set from the MongoDB itself. So, but in our case, our front end is looking for an ID field, and this version, the MongoDB version, is not relevant at all. So there's a small workaround we can do to remove those things. So let's see how we can do that. Let's go to the schema itself. One is there. Okay, here. Let me just. Okay, I'll just copy this code here and I'll explain what it does. Okay, so when we are calling this find method, when fetching this and when converting these models to JSON, we'll call this toJSON method in schema. So what we are trying to do is we are trying to create a new ID, and we are trying to put that underscored ID field to this ID field we are creating. So, and we can also remove this one here and remove the versioning as well. So now that we have added this, let's try and see how this works here, whether this works properly. Okay, yeah, it works perfectly. We have the ID here, and we don't see the MongoDB versioning anymore. So yeah, that's pretty much it here. And I'll quickly try to create a post method and see whether what we can do there. So for that, let's go to the service again, and let's try to define another function. Let's say this as create to do to be specific, and let's try to create something out here. Okay, okay. So while creating a to do, we'll specify whatever the body for that to do. I'll say that as the to do body. So we can use the same model, and we can use the same scheme here, and we can use the create method here. Just pass the body from here. Okay. Now it's very simple. We have this. Let's try to export it. And since it's an async operation, I'll add this one here as well. And let's go to our controller. Okay, now we need another method. Let's copy this one, and let's say create to dos. Okay. Now instead of this, let's try to use that one. Create to do. Should be create to do, right? Because we are creating a single resource. Okay. Now here we can do what we can do is, so whatever the body sent by the client, it is we can access that from the request parameter here. So let's try to access it here. Okay. Right. And here, so guys, whenever we create a new resource, we can, rather than sending 200, we can use another status code, which is 204. So which is called the created status. Let's try to put it here as well. Okay, it's here. Okay. All right, it's there. Okay. So now from this method, it won't return to do's, but a to do which is created. So let's name this as to do, and we can choose to send it here. So whenever we hit this endpoint, the result would be the newly created to do. Let's try to export it here. Okay, all good. Okay, now let's do this. Let's create a post request to this endpoint and see what happens. Okay, so we need to have a body here, and let me try to copy one of these these items. So okay, we copy it here. Okay, zero. Okay, and we can choose JSON here, and this ID will be automatically created, and we don't need the created or the updated at timestamps because they will be automatically created. So let's modify this. Okay, let's change the status. Created. New request. Let's say the case. I think it's not here. Okay, we don't have something like, yeah. Okay, and let's try to create this request. Will this work? Okay, we have to spin up the server. Okay, we are getting an error here. Let's see what's the issue here. Okay, so guys, it's JSON. Okay, see the headers. Okay, so a concept that we discussed earlier is something called middleware. So I told that we'll get a good example here. So in Express, what happens when a post request is created? So it'll get this request, and it won't be able to process the body created there. Since so that in order to mitigate that, we have to add something called so a middleware to get this body, create the JSON body from the request and assign into the request.body parameter of the Express. So for that, we have to use a middleware. So let's see how we could use a middleware here. So we used to use something called body parser previously, but now that Express have their express.json, we can use that. Let's see whether this works. Now we have added that. So yeah, it's still not there. Okay. It's JSON. Okay. All right. That's because we haven't we didn't add the route there. Let's go to the routes. Okay. Let's add something like this. Okay. Okay. This work now. Okay, guys. Finally, we can see the status here as created. And so let's go through these headers. So and one more thing, let's quickly go to our control. Okay, it's here. Say okay. Let's go to the headers. Okay, here what we can see is when we have chosen type JSON here, we can here see the headers. We have something called content type. It's application/JSON, but let's try to change it here. Let's say it's text, and we can see the headers. The content type is text plain. So one good thing is enforcement will automatically change these headers whenever we change our response type here, the request type, the body type here. So yeah, I think we are reaching our time limit as well. Sukitha? So okay, so we were able to create just 2 endpoints, but we have the patch and the delete as well. But let's see whether we can share this code base with you guys with the completed version. And I'll pass it to Sukitha because he has something very important regarding the Swagger documentation. So yeah, Sukitha, you can go ahead.
Can you please mute? Yeah, thank you. So we are almost complete our time, and then here what I'm going to do, I'm going to just go through the code which Randilu has done, and then see like whether I can add something more to that and make it more usable. So here Randilu talked about routes, and his final one we could see, I think you could see my screen, right? So you could see like more get, patch, and delete are there. So basically here the API documentation is very important. And if I go to the give a second. Yeah. if I go to the documentation, so there are like few things. REST APIs are like self-descriptive, but the problem is there are a few things we don't understand. Basically, about the body and basically about the headers, how we pass the authorization information, what are the like schema type. Now Randilu created a schema. Now we don't know what properties are there. If you give this this API to third party, build some application or mobile application, then there is no way the third party knows how to implement it, what are the properties. So because of that, API documentation is very crucial part. The main thing is when it comes to a large project, it implements by multiple parties. It's not just single team go and sit and build the end-to-end. So that's why the documentation is really necessary, and this is one of the best documentation we have seen. This is Twilio. So in the Twilio, you could see the REST API, how they have documented it. So it's a really nice documentation. So there are different specification to define these documentations, and the most popular one is Open API, the Swagger one. And here I'm going to show you the one which I showed you in previous one of the previous slides is this pet store that from Swagger, and this is the Swagger specification, and it will provide something like this. So what I've done, I've created this Swagger output, this specification documents. There are certain libraries like Swagger Autogen. When you pass your routes, it creates you the shell of the specification. Then you can go and do some changes, and you can add host base path in some of the description, and then you can implement schemas like one which Randilu showed, and then you can feed it to the, then you can go and add it to your routes. Here I have added under doc, I have added Swagger UI, and then I feed this file I've created. Now let me run this project, which included the documentation. And then let me go and see whether the documentation is already there. Yeah, this is the documentation. So all our implement methods are here. Now, let's say I want to go and get all the to-dos stored in the database. So the nice thing is I can go and try it in this particular UI without even writing any code. So here you could see all the items, and then let's say I want to remove the eat cake which the Randilu created at last, and I just want to let me try to get that item. And so you could see here that item is visible. And then if I want to go and delete, I can just paste the ID, execute it, and it is deleted 204, some successful request. Now I'm trying to retry to get it. So now item is not there, it's already deleted. So I can see that 404 item is not found in here. So this is basically how we do the documentation. Sorry guys, like there's no enough time to explain all these things. There are like more items I have, but I don't think we have enough time to discuss about these things. And these are the I'll give you like few item to study yourself. You can go read about the middleware chaining. Randilu already talked about that. It's a sequence of functions we execute when we get the request, and then we can do certain operation on top of that, like passing the body, authentication, routing, and then validate the input, and lot of things you could do using the middleware chaining. And there is some sample in our Git repo. We'll share it, and then Then we have like authorization, and we can implement using the middleware chaining. But we have some code here. We have like implement some middleware, and we have valid JWT validation middleware is also implemented, and that we don't have much time to cover all those things. So let's wind up the session here. So I think we can go to the Q&A session.
All right. Am I audible? I think I'm right.
Yep.
Yes. Okay. Thank you so much, Mr. Sukitha and Mr. Randilu, for that very informative and practical session. Now, ladies and gentlemen, it's time for the Q&A session, and we do have some questions. The first question is, why is MERN stack so popular?
Okay, let me answer to that. So MERN, basically, this is completely a JavaScript based stack. So any like full stack developer, any front ender can easily go and build some API and build some small project on top of that. So and things like Node.js are really popular today, and that's one reason the MERN stack to get popular. So basically it's a full stack where one person can go and build end to end. So it's like if you know how to write JavaScript, you can go and write the React front end and as well as the Node.js backend. So that's the main reason I think it's popular.
Okay, the next question is, what is the future of MERN stack, and what kind of a role would it play in the future?
So any software has a like life cycle. So this is the hype of the stack. So it will like in the not in the near future, but in some days, like it will go and there will be like new stacks. But at this point, the stack had like a lot of things, but it's we don't have to like depend entirely on this particular stack. We can change the database. So Mongo might not be the suitable case for you. We can plug it out, and we can plug something like DynamoDB or some scalable database there. So it's if we take it as a whole stack, then there's more there is wide variety of implementation for like combining these with other stacks. So that's how I see it. So it will like help developers to like come into the industry and start working on that and build startups and build new projects. But definitely when it go to more like scalable solutions, there will be like different combinations you will see.
Okay, the next question is, someone's asking the roadmap to learn MERN, if there is a roadmap to learn.
So basically you have to start with the JavaScript, and you have to learn ES6 features, and then you have to go and learn some Node.js. Then that's the main point where you can start. The TypeScript with the superset of JavaScript, you can learn that. So once you good with the language, good with the design and all the like small things provided by the language, then you are ready to go and learn the next layer, the layer of framework, layer of library. So somehow like you have to learn the language first. That's the main point to start.
Okay, the next question is, if we were to create a Jamstack backend from Node.js, since Heroku is no longer going to keep the free tier, what services would you recommend for hosting backend?
So basically in our application also, we have created the serverless framework. So you could use the serverless framework, and you can go with the free tier of AWS. So you don't have to payload, but you have to pay for, like, if you deploy a serverless application, then you have to pay something, but it's not it's not costly. It's like something like few dollars. So I think AWS is the best place to go and deploy your application, but make sure you're using serverless components, you're using Lambda function, not servers. If you buy server, like if you take a minimum server, that will cost like $5. So best is to go into the serverless and then use like serverless technologies like Atlas, as we use. It's a free like the basic one is free, right? Yes. So then try to find the combination. AWS and Atlas would be great.
Okay. The next question is, what is DOM? How it works for reusable components?
Okay, so basically what Randilu done there, without connecting to the, without writing MongoDB queries, he managed to create the model and then execute operation on that, like find all, create, which are like pretty much JavaScript methods, right? So he didn't have to go and write all the queries. So that's the main idea, main thing behind using ODM. So you write the model first, then you just create the connection, and then make sure you call the correct methods rather than go and writing the database specific query.
All right. We have one more question, the final question. What is WebSocket and how to implement WebSocket with API?
So basically, WebSocket is a persistent connection between server and the client. So if you want to, use some messaging, or if you want to send some information to a dashboard, it's always good to have a connected socket. So it's really easy. So you can push data rather than go and query and pull data. So REST is not for that. REST is just always for go and query and get data out from the server. So if you are planning to implement WebSocket, there are things like socket.io, which is like not exactly WebSocket, but they have like WebSocket implementation underneath the main library. And other options are you could use GraphQL. GraphQL has subscription. So if you implement the subscription, they make sure that they have WebSocket connection open, and then make sure that front end get the messages when you subscribe to that particular like method. So here, like REST is not for that. So you could use socket.io or GraphQL to implement WebSocket.
All right. I think we have one more question. Is there a repo we can access for the source code?
Yeah, there's a repo. Yes. We will share the URL. Should we share the URL here? In this particular chat?
I think, yeah, you should be able to share it.
Yeah, what we will do, we will share the URL here, but we'll make it public later. Okay, so let me share. Yeah, we will make it public. I'm sharing here.
All right. That wraps up the Q&A session and the end of the first day of the MERN Stack webinar series. Thank you so much for joining in. And thank you once again for our mentors for doing a remarkable job. And the recording will be available after the second day, which is tomorrow. So do stay tuned with us and join for the next session as well. And also the the reference materials will be shared with all the registered participants. And yeah, that's it from me. It's been an honor being your host for this evening, and have a good night.
Good night, everyone. Thank you.